Okay, guys. Uh, what you are doing today. Uh, Something you've probably never done before. All of you have probably seen because you're at a point now where you've had a scientific calculator. You probably saw the SIN, said, oh, there's sin, and cos, and tan. Well, actually, you're pronouncing those incorrectly, but if I was to see that, that's what I'd call it too, right? That's how it's spelled. Um, we are going to learn the basic idea about those two things over the next 2 days. Yes, this is trig, but no, this is the most basic kind of trig there is. What you're going to fight most of the time today is realizing that you're dealing with something you've never done before. Okay? Like I've told you before, one of the hardest things about geometry, I think the thing that people struggle with in geometry is the fact that a lot of it's so new. You're so used to things building on itself. The concept of some of the things we do in geometry are very new. So of course at the top you need to label, what is the title of this section? Trigonometry. I spell it. Trigo. Trigonom. What's next? Okay. I've called it trig my whole life too. That's probably why. The basis of trigonometry are these things, and they are called your trig functions. That's what we're doing. Okay, so write this down. Everything you do it, you're doing right there. Your trig functions. Your trig functions. Sine, cosine, and tangent. You can use these when you have a right triangle. The abbreviation for each. That's what you see on your calculator. Abbreviation for the cosine is the COS. Abbreviation for tangent is TAN. What these are is something that happens, a ratio that happens always in right triangles. You have a sine ratio, your cosine ratio, and your tangent ratio. I'm going to write a little note down here. You always find the sine of some angle, cosine of some what? Angle, and tangent of some angle. That's kind of an important thing, something that gets lost sometimes. You're going to hear me talk about opposite over adjacent, opposite over hypotenuse, a bunch of things like rules for remembering the trig, your sine, cosine, tangent ratios. But what gets lost sometimes is that you're always finding the sine of an angle, the measure of that angle, like the sine of a 60-degree angle, the cosine of a 60-degree angle. You will have three things involved. You will have the angle and two sides in your trig ratio. Okay? And here's how your ratios work. Sine of theta, which that theta represents an angle. Okay? Is always equal to the opposite leg over the hypotenuse. Cosine of theta, some angle, is always equal to the adjacent leg over the hypotenuse. And tangent of some angle theta is always equal to the opposite leg over the adjacent leg. Those are your trig functions. You will see a little acronym to help you remember it that you will see used time in and time again. SOHCAHTOA. Kind of catchy. It is a little saying to help you remember which one is which. So I got this part down. Let's get that written down and then we will discuss a little of this. Like I said, the concept is very easy first. You had better be able to understand and find those sides, but if you think about it, you're just dealing with three numbers. And I'll let you know a little secret, the calculator will do a lot of the hard work for you. You have to have a scientific calculator to do this assignment. If you don't, you're in trouble. But most of you have smartphones that have a built-in one into it, so you gotta be okay there. Okay. I'm going to leave this over here. We're going to call this X. If you want to, on your paper, you can draw another. Probably need to draw a new one. Go ahead and draw a new right triangle. Make this Y and make this Z. So we're going to talk about algebra. You're going to have two types of problems on your assignment, or actually three types. The first types are going to be able where you're just finding the cosine using a ratio because all three sides are given to you. That's what I want to talk about right now. First thing we're going to do is we're going to find the cosine, or I'm sorry, not cosine. We'll find the sine first. find, hey, what's the sine of A? What is the cosine of A? And what is the tangent of A? That's how you'll see it written. Now, I know that's a little different than you said before, seen before. But what you have to always understand about sine, cosine, and tangent is that this number or variable you see right here always represents a what?
Sine.
No. What did it say in your notes? What did I say in your notes? Everybody look there.
Alright.
You always find the what? Sine of a. You always find the cosine of a. Tangent of a. Okay? That is so very important. Because when I say, hey, if I said to you, go over to the opposite, what would, okay, so if I said you go over to the opposite, what would you ask me? I'm not, nothing to do with math. I just said, hey, go over there to the opposite. What would you say? Exactly. You could say the opposite of what? Right? You see what I'm saying? Or you go over beside. You'd say what? Beside of what? Right? Think about these words we're using here. How are you supposed to know what the opposite leg is? Because opposite is opposite of something, right? So what are we talking about in perspective to here? The thing that's always beside it. That's why the angle is so important, because you have no idea what the sine of A could be if you don't realize that you're always talking about the opposite of the, with respect to the what? Angle. You see what I'm saying? The adjacent to the what? The hypotenuse stays the same no matter what, because the hypotenuse is the what? It's the hypotenuse, right? But if you think about it, there's two legs, isn't there? So that's why the word opposite and adjacent are dependent on being opposite of something or adjacent to something. So when I say find the sine of A, and you look over here, okay, Coach said sine is opposite over hypotenuse, right? Opposite leg over hypotenuse. Well, I'm opposite of what? Well, we want the sine of what?
Okay.
So that would be, you have to go over here to A. Tell me right now, this angle right here, what's opposite, what leg is opposite that angle? So whatever that measure is, you put y right there. You see what I'm saying? Does that make sense? Now, what do I put on the bottom? The hypotenuse is always opposite the what? Right angle, so what's going to go on the bottom here? Now, how does that change? I ask you to find the sine of C.
You want to be doing it
Why? What changes now?
the angle which you're
The perspective of which we're speaking of, right? We were talking, with sine of A, we're talking from this perspective when we say opposite or adjacent, right? If I say find the sine of C, I'm talking from this perspective, aren't I? Now which one's opposite? Yeah, from this angle, the opposite is x over what's always the hypotenuse. So do you see how when someone says to you it's really easy, or you probably talk to someone who's taking trig and you do that joke, oh, those are easy. Because they're used to seeing these words and understanding what it is easy, isn't it? I mean, really, was that hard? I mean, I asked you the opposite, and if you know how to find the hypotenuse, that's really all the math there was, right? So the most important thing is understanding the language. Like I said, that's the key to life. It's something you've never seen before, or probably never thought about. Let's put it that way. You've probably seen it. So how easy is that? It's pretty easy, isn't it? So now should we be able to find the cosine of A?
Yes.
Okay, let's look at that. The cosine of A. What's the difference about cosine? It's adjacent leg. Now, the hypotenuse is always the what? Hypotenuse. You take out of that of the adjacent category, meaning beside. If I go to A, which leg is beside A? X. Obviously, that's the one opposite. That's the one what? So that would be X over the hypotenuse, which is always what? the same thing in mind, now let's find the cosine of what? C. What changes now? I'm talking from a different perspective now. I'm over here talking about with respect to. That's why knowing its cosine of an angle is so important. What is the adjacent leg to C? What's still the hypotenuse?
Z.
That's pretty easy, wouldn't you? What do you guys think?
So hypotenuse is always in the bottom.
The hypotenuse is always opposite the right angle. It should always be your longest side, correct? So it won't always be at the bottom, the top, or don't try not to think of it like that. Try to think of it as everything basically works off of that sucker right there, the right angle. Boom. That tells you where hypotenuse is, which in turn tells you what your legs are, okay? Everything works off that.
So does it matter if does it matter where you put it though, or if you're wrong, if you do put the hypotenuse somewhere else?
Yes,
Okay.
of course. Well, I mean, it's always opposite the right angle. If you say that's the hypotenuse, you're gonna be wrong, aren't you? Right? Everything works off that right angle. If you don't have the right angle, then you can't use trig functions. Okay? Now, tangent of A. What is tangent? Tangent, okay, so I'm saying A, so I'm talking with respect to this angle. Tangent is opposite leg. Boom, right there. What is that? Over what?
X.
What one's adjacent? X. Now let's find the tangent of C. What has changed? The rules haven't changed, but our perspective has changed, has it not?
Yes.
What is the opposite leg as far as C is concerned?
X over Y.
And what is the adjacent leg?
Y.
Finish writing that down. Now, using numbers. Do number 1, 2, and 6. It's okay if you're wrong. It's fine to make a mistake. But once you've gotten this written down, and if you're unsure, look back to this. The concept hasn't changed. It's just instead of variables, I've got actual what there? Numbers. One, 2, and 6. They have changed how it looks. Right, but you're wrong.
Yeah. So do we use all of those?
No, it's one of these.
Okay, so you see.
I'm asking one question, the sine, the first one's asking the sine of what? Or the cosine of what? So I'm only asking that question right there. You see what I'm saying? And the A is there to tell you what? Which angle to go to. So, looking at that, I bet I know everybody got this where I can erase it? Okay, and I know our pictures won't be exactly the same here, but on number 1, they ask for the cosine of A, don't they? And is A right here?
No.
Okay, so it's like this.
Yes.
A's right here,
Yes.
and C's right here. What's this?
41.
What's this?
9. 9. 40.
Okay, the cosine of A. Well, I have to use that general rule. The cosine of A. The A tells me where to go to and what perspective I'm talking about. The cosine is what? Adjacent, which is what? over the hypotenuse, which is,
That's why I do the step.
you're done.
But do you think that you don't like?
Well, can you reduce that?
I mean,
41's a prime number, isn't it?
Yeah, that's right.
You're done.
usually,
But could you reduce it if it was like, if
The next one.
6 to 8?
The next one, and I'll draw the picture, it's kind of up and down, isn't it like that?
It's the other way.
Other way around, okay. I'll draw it up here so it won't confuse you. But number 2, kind of looks like that. What's this?
A,
What's this?
C,
What's this?
B,
What's this?
24, 10, 24,
What's this?
9, 30,
What's this?
30,
Okay. So for that one, what do they ask you to find here?
sin of A.
Sine. Sine of A. Okay. Well, what is our perspective? That one right there, right? With respect to that, it's the what? The length of the opposite leg. What's the opposite leg?
24,
Over.
30,
What's the hypotenuse?
30.
Now, why is that incorrect? It's correct, but it's incorrect.
It is.
I mean, in the world of math, what have you learned painstakingly and through lots of fighting and being mad about having to do it, that you have to always do with fractions?
Simplify.
3 goes into that 8 and that 10, and that still won't work, but 6 goes into that what? 6 goes into that? So the sine of this angle, whatever its measure is 4 over 5. See, there's no angle measures in these, are there? That's what we're going to do next. Okay? Right now, they're just asking you to find the sine of A and giving you what? The length of all 3 sides. You make a mental note that there's 3 types of problems on here. Problems where they give you all 3 sides and say, hey, find the sine of A. And they don't even tell you what the measurement is. There's going to be problems where one of your sides is your unknown. And they give you the angle measure. And then there's going to be ones where your angle is your unknown, and they give you the 2 sides. Okay? Yes?
There's nothing wrong with like calculator and.
We'll get into the
Sin
calculator.
one.
Sine.
Stuff. Sine.
We'll get to that. Because that's a decimal, isn't it? Isn't that point 8? You know what we just found? We'll get to it, trust me. You'll be disappointed when we get to it. It's not that bad, but. Okay, and then the third one, or number 6, what was it? It was, now this one was like this, wasn't it? What was this?
Other side.
Yeah, the electric.
What's this?
A, B, C, 21, 29,
They actually find the tangent of what?
C,
Okay, tangent is what? Opposite leg over adjacent leg. We're talking with respect to this angle, are we not? What is the opposite leg? Over, what's the adjacent leg? Will that reduce any? Yeah. These ones on this first page are extremely, okay? But what they are great for is teaching you the concept of always with respect to this angle. It's not what you'll do most of the time with these. This is the purpose of these, to let you guys realize that you're always talking in terms of what? The angle that you're finding the tangent of.
So is the adjacent leg is always the other leg, same
It's the one that's not on, it's always, best way to probably think of it,
leg?
it's always a leg, yes, it's adjacent leg. Now, back to SOHCAHTOA. You won't hear the leg part on the end, but you'll get used to it. The hypotenuse is always the hypotenuse, so you ought to be able to figure out which one is adjacent. So, what do you think that's talking about? What's the only one that starts with an S? Sine. O, opposite. H, hypotenuse. Cosine. A,
Adjacent.
H,
Hypotenuse.
hypotenuse. T, test, I mean. Yes, of course you can, but you know, you'll find that a lot of people, all we're going to do today is set up problems to find the missing side or angle using trig functions. That is what we are going to do today. If you'll notice on Canvas, what should have been yesterday before family got all sick, and I had to not be here, today we're setting them up. So we're not going to talk about the calculus yet. Okay? Tomorrow we'll solve it. Okay? Do it 2 pieces at a time, where it's not all on top of itself. Here's another thing to write down. 95% of the time, and of course that's a rough guesstimate. The problem will tell you what trig function to use. By the information given. I don't expect you to necessarily understand exactly what I mean when I say that right now, but you will here in a second. I want you to draw 3 actually, let's make it 4. 4 right triangles. And I'm going to give you 4. Well, yeah, 4. If we have to do another, we'll do another. I'm drawing mine upside down, in case you're wondering. Unfreeze, there we go. Drawing mine like this. It's tough being able to, I really think it's better when I can point and talk to you guys teaching you this. So that's why I try to, God, I can't even see the other one on here for some stupid reason. Do we have both lights on again? Turn one of the lights off. Turn the other one off. See? And then turn the other one on that wasn't on before. It just overexposes right there. There we go. That's a little better. I know this could be a pain waiting on me to do this, but I'm just trying to where you guys can watch this again if need be. Okay. Here's what I mean by this. I'm going to put some examples up here, okay? the type of problems you were gonna have to solve. I just have to stop. That's all I want you to do for your homework tomorrow. Is I want you to set up all these. There's a bunch of them, I realize that. But it shouldn't take long. Honestly, 20 minutes maybe, at most 30. So everybody right now get, just so you don't get distracted, go to the second page, The directions are finding what? Missing side down to the nearest 10 or 100, which one? 10, okay. I don't care about you finding the missing side right now. I care about you setting it up and understanding this concept. Most of the time, basically, sometimes they'll give you more information than what they need, is why I can't say all the time. But here I'm giving you the bare minimum. By the information given to you, they tell you which trig function to use. Okay, how do we always figure out what's what? Okay, SOHCAHTOA. So up here, sine is equal to what? Opposite over what? Hypotenuse. Cosine is equal to what? Adjacent over what? Tangent is equal to what?
Opposite over adjacent.
And that's how you'll end up probably memorizing them and thinking of them. Okay? Opposite over adjacent, blah, blah, blah. That's how I always do it. Number one here. Number one tells you what trig function to use. Can you guys tell me, can anybody see what I mean? What trig function are they telling you to use here? They're telling you to use sine. Well, why do you think that is? How do we always find opposite with respect to what? The angle, right? What angle did they give us?
The opposite.
This angle right here, the 45-degree angle. So always, always, always find your what first?
Angle.
Find your angle first. Because, like you said, just remember me saying, okay, so, hey, go over there to the opposite. You all look at me like I'm crazy. The opposite of what? Well, you've got to find out what is first too, don't you? Then, when you find out what it is, you can find out what's what? Opposite, right? So, with respect to this angle, they gave you the what? Opposite? And what's this? That's what I expect you to write on every paper. That's the first part of setting it up. I want you to tell me what they gave you. And you can abbreviate it like that, OPP and HYP. They gave you the what? With respect to your angle, I want you to circle your angle. Okay, I want you to do exactly like I'm doing. I'm trying to train your minds. I know, once you figure this out and you're on your own, do it how you want from, after my class. But I'm trying to train your mind to figure out right here. First thing we find, your angle, circle it. And then say, what do you have? I have opposite and what? What does that fit to? Sine, cosine, or tangent? See how they told you by what they gave you? They absolutely told you which one to use. So you're going to set this up and leave room to solve. The sine, what do we always find the sine of? And the what? Angle. What is our angle? Is equal to the opposite, which is what?
X.
Over the hypotenuse, which is what? You said that one. I'll talk to you about how to solve it tomorrow. One step at a time. Yes.
Would you, like for number 13 on making the problem, since it's a cosine, would you make it the same way, x over 13?
Absolutely. And okay, now let's go to number 2 here in our examples. What's the first thing we find?
Angle.
So circle. There's where our angle is. With respect to our angle, what has been given to us? What's that? What am I going to label it as? Adjacent. Right, ADJ. What is that?
Hypotenuse.
Label it what? HYP. So, has the problem told me what trig function to use? Yes, they gave me the adjacent hypotenuse. What's the only one that fits in? So, it's always cosine of an what? Angle, which our angle is equal to the adjacent, which is over the hypotenuse, which is, set that one up. Like I said, don't freak out on how to solve that now. It's easier than you think. Okay? One step at a time. So you can see how you can get this done pretty fast, just going through those and setting it up, labeling them and setting them up. Our other type here, what's the first thing I find?
Angle.
With respect to my angle, what's been given to me? And what's this?
The adjacent.
What does that fit into? What have they told me to use?
Tangent.
Which one is opposite of adjacent?
Tangent.
So tangent of what? An angle, what's our angle here? Is equal to, well, what's the opposite? Over
7.
Now, one thing I wish I would have done different, you'll have the X at the bottom here some too. Don't think that the X is always at top.
Is that if the hypotenuse is the x?
Yeah. Okay. Wish I wouldn't have done that. So don't always think your variable's on top. Everybody understand? Yeah. And that's the thing, guys. Think of it as generally as you can, but don't jump to conclusions. Make sure you follow your rules. Okay? I mean, all I have to do to change this one is make this what? Now what would it be? Now I would have put it as this. Everyone agree?
Yes.
Okay, I'll change it back. Now, this was number 3. Last one. Number 4. Just because things are a little different, don't freak out. The rules have not changed. What do we find first? What's our angle? With respect to my angle, they've given me the what? Opposite. And the what? So what have they told me to use? No, there is no sin. Thank you. Sine. Now, it's always sine of a what? Angle. What is our angle here? Sine of x is equal to the opposite, which is 20, over the hypotenuse, which is? And if you'll notice, turn to page maybe 4. Look at that. I want you to not to make those question marks, make them X, okay? Can you do that for me on 33 through 44? Yeah, I mean, treat it, or you can use whatever variable you want, but it's the unknown, right? So what do we need to use? A variable, correct? Those are ones where your unknown is your angle, isn't it? And it's good that those are separated on here because you solve those in a little bit of a different way. Or you actually do
So the
something.
question marks up the X's.
X or Y, Z, I don't really care. When you put it in, when you set it up, you're going to need to use a variable, correct? You don't use question mark. So, that's your assignment for today. Get to work on it. This, I want you to set up all these. Then go start on 1 through whatever. But I want you to start on page 2 right now. And try to set them all up, label them, circle, label, write your trig function. Okay? I'm telling you, it should be 30 minutes of work. Then when you get here tomorrow, we'll be able to jump to some and say, okay, look at this one. This is how we solve one that looks like this. This is how we solve one that looks like that. Okay? Don't freak out, like I say, because those of you that have problems, there are people out there that when it completed, it's going to drive them nuts. They can't complete it. You are completing your assignment by doing this. We'll complete the other part tomorrow. Your assignment is to just what? And honestly, is that very hard? It's a very simple concept with kind of confusing and odd names. Put it that way. Okay? I didn't mean to use the whole hour. Did I? Okay. Try to get that done tonight. It's just, it's important we talk about this and you understand it because it is so new.